Right, and there we go. I think we are live. I don't know because I'm useless when it comes to anything technological. So you're gonna have to let me know in the chat if you can hear me or if you can't hear me or whatever. I'm kind of lost without my wingman Creaky. He usually sorts all this stuff out. Anyway, it is, if you can hear me, it is Flat Earth Week on Agree to Disagree. We're not a Flat Earth channel, and we've always said we're not going to be a Flat Earth channel. We've always said we're going to be a channel that does all sorts of debates of all sorts of topics. But Flat Earth falls into that category as one of the many topics. So I thought that was a message from Creaky telling me that I'd messed something up. So this week, on Wednesday, the live debate is going to be a Flat Earth debate, and it's going to be myself. I'm going to be taking the hot seat against the mind of God. And tonight's a little bit of, how can I put it, a little bit of preparation for that. Now, at Agree to Disagree debates, you'll have heard us talk time and time and time again about how we want this channel to be full of civil debate, how we want people to be able to educate each other and listen to each other without shouting over each other or belittling each other. And I think if you've seen my last couple of debates with Standing for Truth, for example, on creationism, you'll see that that's definitely the route I'm trying to take. But I've not always been like that. My second ever Flat Earth debate was against the man on the screen here, Nathan Thompson. And if you're new to the scene, you might not have seen it. And you'll see a very different debating style from me. And I'm going to review this tonight. I'm going to sit and I'm going to watch it with you. And I'm going to answer any questions you've got. I'll pause the video. We can have a chat about it. Please tag me in as Agree to Disagree, because I'm signed in on that account, not the Conspiracy Cats account. And I'll pause it and I'll answer any questions you've got, and we'll just have a laugh and a chat. If you've seen the debate before, it is a rerun. Right? It is preparation. Wednesdays won't be a rerun. Wednesdays are going to be live. But if you've not seen the debate before, then it is a fun one. Let's have a look who we've got in the chat. Let's have a look. Oh, Rune Thompson, hello. Hi, Deanie. Say hello to our moderators. Oh, Team Skeptic, great job last night. He also debated Standing for Truth last night, and creationism did a great job. Crafty Keeler, hi, Deanie. So many people. Oh, blimey. Oh, cheers, partner. Thank you very much. Comb your hair, you scruffy cat. Look at that. What's wrong with that? Thank you very much, Creaky Blinder. You are very kind. Right. So what I'm going to do is I'm just going to tell you what my tactics were sort of in this debate, so you can see maybe why I acted the way I did. And then we'll watch it together, and like I said, tag me in and we'll have a chat. The whole idea going into this debate was that Nathan Thompson at the time was a much bigger channel than I was. And he had his Facebook group, which was the biggest Facebook group on Flat Earth on the internet, over 100,000 people. You hear him banging on about it all the time. And when I went into the debate, I knew there wasn't a hope in hell, really, that by the end of the debate he would admit that the Earth was not flat. So I went into the debate with the sole goal of showing everybody in his Facebook group and everybody on the edge watching that he had no idea what he was talking about. So every time he brought up a piece of evidence, I wanted to demand that he explain it, and of course he couldn't explain it for anyone who's watched it, and that's what makes this so much fun. So what I'm going to do, I will be back in a second. If I do that, I should have disappeared, and if I do that, I should have disappeared the border, so I am here. And I'm going to hit play, and this is just after we've done the introduction. We had a little bit of a technical issue, and when I see questions that bob up in the chat, I'll pause the video and we'll answer the questions. Other than that, enjoy.
Okay, so I won't start over, guys. I'll just real quick reiterate. Nathan Thompson, I run the official Flat Earth and Globe discussion on Facebook. The only barrier from the truth is the preconceived notion. You already have a globe earther for 30 years. I didn't even think this was something worth researching. I don't want to be a flat earther. It's just all the observations and experiments I do lead me to believe it's a flat stationary Earth. And the history of the heliocentric model is very obvious that the science has been hijacked and modern astronomy has been hijacked. And I really think these discussions are great. They promote dialogue in an area where it's all dogmatic and people think everything is settled, and the only people who can give us information are the Delphic oracles of the heliocentric priesthood. So, but what happened when they hijacked science is they turned it into a religion of double speak. So what ends up happening is you ask globe earthers about the Coriolis effect, and they tell you that objects move separate from the rotating Earth when they're in the Earth's atmosphere. And then you ask them about hot air balloons and airplanes, and they tell you, well, the atmosphere rotates with the Earth, so there is no Coriolis effect. Now, they do the same thing with curvature. It's a hijacking of perspective. There is lots of evidence that light bends, but zero evidence that large bodies of water, when at rest, are bending or vertically dropping downwards 8 inches per mile squared to account for the curvature of the Earth. Also, the rotation and movement of the and all supersonic speeds are purely theoretical, guys. The floor does not move 1,000 miles an hour at the equator. We are moving around the sun at 66,000 miles an hour, and we do not travel 20 million miles a day through space. Now, I hear all the time, where's the edge? But if we're traveling 20 million miles a day through space, I want to know when we're going to hit the edge of space. So also, space is fake. That's why the entire heliocentric model, if you try to look up Google pictures of it, it is a cartoon. So there's no real pictures of the sun. There's no real pictures of South Pole. There's no real pictures of satellites in space. We don't have any real pictures of the solar system. It is all a cartoon. Now, the reason they have to fake space is because space would violate a natural law. That law is the second law of thermodynamics. Now, in comes the doublespeak from the globe earthers, because Conspiracy Catz recently made a video saying, second law of thermodynamics does not apply to matter, it only applies to energy. But Einstein showed us that light and matter are just aspects of the same thing, with his famous quote, E equals mc squared. Now, I'll get into it in more detail later because it is one of my main points, but you have classical thermodynamics and molecular thermodynamics, and it definitely involves matter. So, guys, please, I know everyone has their preset beliefs, but we're not here to talk about beliefs. We're here to talk about evidence and what we can prove, and science is a very narrow method. It empirically proves things. You get a 1 or a 0, a black or a white, or to use the analogy, a yin or a yang, which from the beginning of time is a flat earth map. All the ancient civilizations knew not just that the earth was flat, but that the sky was a map. We've been celestial navigating with it using since. The pole star in the north is called Polaris because it doesn't move. That's what pole star means. And when I say doesn't move, I mean relative to all the others. Yes, I agree. There is precession. Sun and moon are separate lights. The moon's not reflecting sunlight. They are two separate energies. How am I doing on time, Simon Dan? Because I feel like I'm going over.
You're just about done, buddy. Yeah, you're just about done. Thank you very much. Apparently the chat has crashed. Yeah, but right, okay. Thanks very much for that. That's your 5 minutes. So Conspiracy Catz, 5 minutes. Away you go.
Right, cheers, cheers, Nathan. Look, the arguments I'm going to put forward today is that. So I was muted through the whole of that, wasn't I? Yeah, absolutely brilliant. No technical issues whatsoever. Yeah, you know what? What I said then was so profound and so important that I will cheapen it if I said it again. So those who could hear it, you were very, very lucky. No one will ever say anything as profound as that again. I'll get with my introduction. Fire me some questions, and when I see one, I'll pause the video and I'll answer it for you. Literally, the flat Earth model predicts literally absolutely nothing. As a model, it is incredibly pointless. Let me just run you through some concepts. The globe Earth model can accurately predict day and night. It can accurately to the minute predict sunrise and sunset perfectly. The flat Earth model can't do that in any way, shape or form without running into ridiculous problems like the angular size of the sun having to change throughout the day, or explaining what mysterious magical force is keeping the sun in that circumference above a flat Earth.
the globe Earth model can accurately predict the seasons, again, to the T, but yet the flat Earth model can't do it without running into problems such as the speed of the sun having to change or the length of a day having to change as the circumference of the sun moving across the flat Earth changes. The globe Earth model accurately predicts and is the only model that accurately predicts our observations of Polaris and how we can predict the angle of Polaris in the sky when we're given a given latitude. However, the flat Earth model, Polaris would physically have to be in a different place for every single person on the planet, or every single person at every single latitude, for them to be able to observe Polaris with that 1 degree shift for every 111.3 kilometers. So the flat Earth model, yet again, has failed to be able to predict even the simplest observations that we make. Circumpolar stars, we can predict that if the declination of a star is greater than 90 minus observer's latitude, it will be circumpolar. There is literally, and we can, and that is reproducible and predictable. I can choose any star and I can decide will it or will it not be circumpolar from any latitude on the planet. The flat Earth model can't do that in any way, shape, or form. There's no explanation for that at all.
I'm just going to pause. I'm not going to do this a lot, but I needed to make more of that point, because you could choose any star in the sky that is circumpolar, and you can predict, based on the shape of the planet, how far south you'd have to travel before that star isn't circumpolar anymore, based on the geometry of the Earth being a sphere. And you can do it, and anybody can do it. And if you try and use the geometry of any other shape, it just doesn't work. You know, I should have made more of that point, really. I think I will do on Wednesday.
And these are the simplest things that the flat Earth model just can't handle. Seismic waves that are used to predict the epicenter of earthquakes. And we all know that as a human race, we can predict the epicenter of earthquakes. They only work on a spherical model to have that equal distribution, or that's how can I put it? That even distribution of P and S waves, no matter where the epicenter of the Earth is, we always get exactly a symmetrical distribution. That will never happen on a flat Earth, and yet time and time again we are accurately able to predict the epicenter of those earthquakes on a globe Earth. So yet again, the globe Earth model triumphs in its predictive capabilities. The globe Earth model is the only model that predicts why we have a clear and defined horizon. The flat Earth model has no idea why a horizon should be so clean and crisp and defined. It just can't explain it. The flat Earth model, again, falls behind the globe Earth model. When we talk about why do things vanish from the bottom up, the globe Earth model explains it perfectly. However, when the flat Earth model tries to explain it, they have to delve into ideas like the Rayleigh criterion, and they get that wrong. If the conversation goes that way, I'll show you exactly why that is wrong. The flat Earth model can only explain why things disappear from the bottom up if either they misrepresent science or just ignore it. Something else that is misrepresented or ignored by the flat Earth model is the aurora, the northern lights and the southern lights, perfectly predicted. We know when we're going to have strong northern lights, and we know we're going to have strong southern lights due to solar activity, predicted brilliantly by the heliocentric model. There's no way for a flat Earth model to predict that. Again, the flat Earth model becomes totally useless. Eclipses, again, perfectly predicted to the minute, and not just to the minute, but by location. Now, the flat Earth model, or the flat Earth explanation for eclipses, is that we just use patterns. Well, the thing is, even if you take, the pattern of I think it's about 18 years, 11 days, we repeat sort of our eclipses, but not in the same location on Earth. And the flat Earth model can't predict at all whereabouts the eclipses are going to occur on Earth, but the globe Earth model can, again, every single time. An equatorial mount, any hobbyist can pick up an equatorial mount and a telescope. There is no way at all an equatorial mount can work on any other shape than a spherical Earth. No model has been put forward. Simple things. Why do objects fall downwards and not upwards when the density of the Earth upwards is less? It's lower than the density of Earth below it. Again, the flat Earth model just can't handle that. Only the heliocentric model can handle it. Predicting transits of planets and retrograde motion. Again, only the heliocentric model can predict it to the absolute T and can explain it. The flat Earth model can't do that without running into all sorts of other ridiculous problems. We could go on and on and on. We could talk about the phases of the moon. We could talk about the ISS and the Himawari satellite. And we could talk about the actual images that aren't composite images. But yet, the only...
I'm afraid that's your 5 minutes, buddy.
Oh, I did waffle on, sorry, mate.
Right, so that is the end of round one. And yeah, for anyone who's wondering what I'm drinking there, it's Canna Carling. I was quite nervous about this debate. I think there were 5,000 people watching at one point. So yeah, I had a beer to set my nerves, and nobody would let me forget that it was Carling. Like, I quite like Carling. I don't know what's wrong with it. Anyway, I was going to say Rune Thompson is in the chat, and he's always a very respectful guy. I know he's a flat earther, and that's not a secret. And I can see him raising some points. Rune, if you want to ask me a question directly, I am watching the chat, and if you want to correct me on something I've said or challenge anything I've said, if you just tag me in on that under agree to disagree, I will happily pause the stream and answer it for you. But now the back and forth starts, which doesn't go well for Nathan. Let's carry on.
Okay, right. Thanks very much, guys. So what we'll do, Nathan, if you want to make your first point, please. Once you've finished that point, please let me know, and then we'll put it over to CC.
Yeah. Can I just, before I make that point, can I respond to what he said?
No, the introductions were just there's no response to introductions, just points only, please.
All right. Well, my first point is that space is fake because it has to be. It would violate a natural law of thermodynamics. Creaky Blinder has recently stated that second law of thermodynamics only applies to energy and not matter. Einstein showed us light and matter are just two acts of the same thing. Matter is just frozen light, and light is just matter on the move. Albert Einstein's famous quote says energy and matter are two sides of the same coin. I think everyone has heard E equals mc squared. Now below is a quote from entropy.edu//entropy is simple. In classical thermodynamics, it is viewing entropy increase as an increase of the dispersal of energy from localized to spread out at a given temperature. Then you have molecular thermodynamics, the system for which there are fewer accessible microstates. Okay, so gas pressure into a vacuum, mixing of ideal gases, diffusion, effusion, coagulative effects, and osmosis each fundamentally involve an increase in entropy. Due to the increased dispersion of energy with no change in total energy, in the case of the ideal substances, due to the greater number of basically high pressure systems move to low pressure systems, we can't have a pressurized atmosphere without a container, and the container definitely can't be a vacuum. That's my argument.
Right, that is his argument. Just had a question. I said I'd address it. Wolverine6668 says, how do the flat earthers address meteorites? And have I got that right? Yeah, meteors like an asteroid like the one in Russia or the one that hit the Yucatan. Not familiar with that one. Oh, sorry, the one that killed the dinosaurs. Yeah, that was a big one, wasn't it? I don't know. What did he say? Like, Rune, you're in the chat. What do flat earthers say about meteors and asteroids? You know, obviously if you're presupposing a dome, how can you have something flying through the dome without smashing the dome? What is the answer for that? Just tag us in, because I am interested. Anyway, Nathan Thompson's made his starting point, and he's told us all that the second law of thermodynamics means we can't have an atmosphere next to the vacuum of space. I wonder how well he understands the second law of thermodynamics.
Okay, thank you. CC, do you want to respond to that?
Yeah, absolutely. There's two things I want to show, if possible. Craig, are you there?
Yep, ready and waiting.
Can you bring up slide 45, please? And I'm going to need that video link that I tweeted you as well, the last video link I sent you.
Okay, bear with me 1 sec. I'll get slide 45.
So Nathan, while he's doing that, my argument, what I was going to wanted to mention before, but it's suddenly become really relevant, is that a lot of people believe that you can't have a gas pressure next to the vacuum of space because they totally misunderstand what the second law of thermodynamics is, or they just hear people like Nathan Oakley or Quantum Eraser rattle off, the kind of stuff you just said there. So just to make sure we're on the same page, because if you're running the largest internet, if you're running the largest Facebook group on the internet, and you're telling people that the second law of thermodynamics says that it's impossible to have an atmosphere, you must you must be really familiar with what these terms mean here, because anybody with a fundamental understanding of entropy will be able to tell me straight away what those terms mean. So just to show everybody that you have that understanding, can you just tell me what those terms mean there? You mentioned microstate. Can you tell me what it means? A macrostate, a Maxwell's demon. They are fundamental basics of entropy. Can you
Thank you very much,
tell me those?
Keeler. Thank you. I have a slide for that.
Yeah. What I stated, microstates is like gas pressures and liquids and stuff that can move around. Macrostates are like solids. So unless you manipulate them, they're not going to just increase or decrease in entropy. I'm not exactly sure what Maxwell demon is, or pretty much what your argument is. You want me to define things? Really just define these and state your argument. So go ahead, state your argument. What is it?
Well, I will show my argument, but I think the first point is if you did have a good grade.
Now, a friend was just joining the chat, and I'll just let the next exchange play out. But my whole argument here is that he's got 100,000 people on Facebook following him. He's telling 100,000 people on Facebook that the second law of thermodynamics means that the Earth can't be a sphere, as we're told it. And he hasn't got a clue what the second law of thermodynamics is. And this next few minutes is one of my favourite I think I've ever been involved in.
Grasp of entropy. Those would be extremely, extremely basic concepts for you to define. So really what I'm making this argument for the people who are watching and the people in your Facebook group and the people who are considering flat Earth to try and show them that literally you don't have an understanding of entropy at all, which is why when I've given you the basic terms of entropy, you cannot in any way explain what they mean. But I've got a video clip here. There's only 50 seconds of it. And this is going to explain quite well the point you brought up. And I'm sure with your brilliant understanding of entropy, you'll be able to explain why this explanation is wrong. Craig, can you play that clip from 8 minutes 50 to 9 minutes 40, please? Are you there, Craig?
Yep, so I'm just getting that loaded up for you. Bear me 1 second.
Oh, so yeah, so 8 minutes 50 to 9 minutes 40. And then we'll assess your understanding of entropy based on your reaction to this clip, Nathan.
And are you here to see what I understand, or are you here to make an argument? What's your evidence? Like,
how far in?
Just here to question me about what I know.
Well, I think it's important to assess. I think if you are, the owner of the largest flat Earth Facebook group on the internet, and you're making claims that entropy says it's impossible to have an atmosphere, then you have to demonstrate you've got some understanding of entropy. And I think if I can show you've got literally no understanding of entropy, then your entropy argument flies out the window, and it's a ridiculous one. So yeah, I am going to hold your toes to the fire, and I am going to make sure that you can show people you've got a basic understanding of entropy. Watch this video.
Does entropy include matter and energy, or is it just energy?
Just watch the video, and we'll come back to it afterwards.
Just make sure the audio's on.
From 8 minutes 50.
Equilibrium is, by definition, the one with the most
8 minutes 50.
And dynamic equilibrium. Okay, so the macro state that defines thermodynamic equilibrium is, by definition, the one with the most microstates, which also means the maximum entropy. Any system not in equilibrium must increase in entropy simply because at any future time, its current microstate will most likely be one of the more common types of microstate. This is assuming you don't force the system from the outside. It's possible to take each glowstone and place it on a particular spot to construct a special microstate, or to use a vacuum pump and a glass wall to move all of the air to one side of the room. In both cases, you're reducing the number of accessible microstates, which by definition must reduce entropy. But to do so, you must introduce an external source of energy. Heat must flow between your system and the outside universe in a way that increases the entropy of the universe as a whole.
Right, Nathan, now I'll explain to you in a minute why that explanation, the proper explanation of the second law of thermodynamics, does not defy an atmosphere. But can you tell me what he said there that you interpret to mean there can, because it was your point. You said there can't be an atmosphere, and you said it was due to the second law of thermodynamics and entropy. So you show me you understand it by telling me what he's wrong about there. Can you understand what he's just said?
Okay. Just to be clear, they didn't say there can't be an atmosphere. It's an atmosphere, so there most definitely can be an atmosphere. My argument was that there can't be space, a vacuum of space, 10 to the negative 17 torr vacuum of space, resting next to our pressurized atmosphere, because the necessary antecedent for gas pressure container. Without the gas in the container, you have no gas pressure. Without the container, you also have no gas pressure. So when that guy was saying that you can apply an external energy or a force and remove all the air particles from the vacuum, well, what's interesting about that is we can't recreate a 10 to the negative 17 vacuum of space. The Sandusky Research Center is about half that strong, and they have 8 feet thick of concrete and aluminum walls to separate. I will agree the atmosphere is more dense here at sea level than you go up, but then you just kick the can upwards by saying, there's less pressure up there because there's still pressure. You can weigh the pressure up there, and as I said before, and I'll end with this, the necessary antecedent for gas pressure are gas molecules and a container. No container, no gas pressure. So second law of thermodynamics does apply to energy and matter. I just went over it with classical thermodynamics and molecular thermodynamics, and I don't understand what your argument is, other than trying to say I don't understand it. Can you demonstrate gas pressure without a container?
And I think that's your problem. I think what I'm showing here is I've asked you a very specific question, and I'm going to ask it again because I want to make it really clear to everybody who's watching what my question is and how you're going to dodge it. I want to make this very clear. My question to you is, can you explain what that guy said that was wrong in the video? Do you understand what the term macrostate and microstate actually mean? Because if you don't, you clearly do not understand entropy in any way, shape, or form. Now, I can give you the explanation of what he said. I can put it into more simple terms for you, but I can guarantee, and anybody watching that video understands entropy now, can guarantee that he's not saying you can't have space next to a vacuum. He is saying that as long as we have this exchange of energy, and he even talked about heat being radiated off, etc., there's no barrier whatsoever. I mean, I could go into more detail, but I want you, because you are claiming to vulnerable people on the internet that the Earth is flat, and one of your pieces of evidence for this is that entropy tells us we can't have an atmosphere next to space. And yet when I press you and I press you, you're dodging explaining to me the simple basics of entropy and thermodynamics. Tell me what microstate is. Tell me what a macrostate is. Show me you understand. Tell me what he said wrong on that video. Tell me now what he said wrong on that video.
And before he fails to answer, I will point out I am aware that I really went on and on and on there, and that was quite annoying. So sorry about that.
Tell me why what he said means we can't have an atmosphere next to the vacuum of space. Can you do that? On the video. Don't tell me about some place that's got aluminium and concrete. Tell me about the video. Show everybody in the chat you understand thermodynamics. Off you go.
This is where we run into the dogmatic problem the religion of heliocentrism has become, to where conspiracy cats, who apparently was a teacher for like decades, just considers some dude on the internet to be some Delphic oracle, and his explanation is scientific evidence for his assertions. Now,
and that to me, I mean, I can't believe that. Let me get my face on camera. So the fact that I've cited a video on the internet is shocking him, because to him, that's not good enough research? I mean, what do flat earthers do all the time other than watch a video of another flat earther saying and doing something and then buy into it? It's crazy, absolutely crazy. Yeah, that argument annoyed me.
Now, I just can end this right here, period. I don't need to give you every definition in the book. You don't need to question me on my understanding of everything. Can you demonstrate, because science is observation, hypothesis, and experiment, can you demonstrate gas pressure without a vacuum without asserting your religious belief about what the sky is and what the atmosphere does?
So let's just revisit, right? You are telling, because you've not answered that question one bit, and I will move on in a second, but you can shrug your shoulders, but essentially you have said that the explanation for the second law of thermodynamics means we can't have gas pressure next to a vacuum. You have invoked the explanation. All I'm doing is correcting your explanation. And you clearly, everybody's watching us, 2,000 people in the chat watching, and everybody can see you have no idea what the second law of thermodynamics is. Now, we will move on, but I've made my point that you can't argue entropy anymore because you don't understand it. Essentially, I will tell you why we can have that atmosphere next to a vacuum, and that is because the gas particles have done that much work against gravity and radiated off that much heat as they go high into the atmosphere that the difference in energy between the high level of the atmosphere and the vacuum of space is very low, and it's not big enough to stop gravity being able to hold those particles towards the Earth. You've got to have big differences in energy for work to be able to be done, and that difference in energy just doesn't exist. Those particles aren't moving, if you like, fast enough for this to happen. So Nathan, this changes because you were talking about pressure.
I'm just going to add something to that. Someone's just asked, Augusto has said, where can I find the full video? This is the full video. It's on Simon Dan's channel. But I'm just getting my face on camera just for a second. He was talking about entropy. One thing I didn't say in that debate was that you do still have an increase in entropy as energy leaves the sun into space via the Earth. And as it's absorbed by the Earth, the energy is carried in the photons, and the higher the frequency, the more the energy, and they're absorbed by the Earth, which then re-emits and radiates off more photons. Now, what happens is the photons that's radiated off by the Earth are of a lower frequency than the ones that are absorbed by the Earth from the sun, which means more, assuming we're radiating off heat at the same rate we're absorbing it, we have to radiate off more photons than we actually absorb. So we're taking that same amount of energy and we're splitting it into more microstates, essentially. Right? We're splitting into a larger number of possible ways it can be organized because we are radiating off more photons than we absorb. And that gets repeated through the atmosphere. So when those photons are then absorbed by the lower layer of the atmosphere, again, they are re-emitted again as a larger number of photons, and so on. So you do get an increase in entropy. Anyway, let's crack on.
An extension to your question, and you mentioned pressure. What is gas pressure? Tell me what causes gas pressure. Tell me the mechanics of it and why that means we can't have an atmosphere next to space. Show all the people that are listening to you that you understand the science. Show them you've got that understanding. What is gas pressure?
Okay, so I asked you to demonstrate gas pressure without a container, without asserting your religious belief about what the sky is and what the sky does. And you said, quote, I will tell you. Okay, so there is no science, there's no experiment, there's no demonstration. It's just words of conspiracy cats telling us how the universe works. Okay, now I will take the second law of thermodynamics in a different way, from a different definition. Entropy of an isolated system consisting of two regions of space, isolated from each in thermodynamic equilibrium in itself, in equilibrium with each other, will, when the isolation that separates the two is broken, so that the two regions become able to exchange matter or energy, tend to increase over time, approaching a maximum value when the jointly communicating system reaches thermodynamic equilibrium. So that's the second law of physics. You asked me to define gas pressure. Gas pressure is easily defined. Gas molecules pressing against the walls of the necessary antecedent, a container. I asked you to demonstrate gas pressure without a container, without asserting your religious belief about the sky vacuum, and you literally just said, I will tell you about the sky vacuum, and then started telling me. So I'm going to ask one more time before we go on to the next point. Can you demonstrate, show me, gas pressure without a container, without asserting the sky vacuum, conspiracy cats?
Sure, no problem. But I do want to highlight before we do that you didn't even explain the simplicity of what gas pressure is. When you talk about gas pressing on something, just because the word press features in the word pressure doesn't mean that's the answer. What happens is the gas particles collide off a surface, and we have a change of momentum when they collide off a surface. And we know that force is the rate of change of momentum. Now, what happens with the atmosphere is, as we go higher, and I can prove this to you, unless you're willing to concede, we have a pressure gradient. Are you willing to concede that?
Of course we have a pressure gradient.
Right. So
hydrostatic is a good example of why we have pressure gradients. Same thing when you go under, the pressure increases. That doesn't mean you can have gas pressure without a container. I'm still waiting for you to demonstrate that. If you can't, just say, I can't demonstrate it, and we can move on.
Well, we can. I'm about to show you, because when you say gas pressure without a container, you're talking about differences in pressure. For pressure to exist, these particles, like I said, they are bouncing off a surface. But if you look at here right now, here, right on my screen, what are these particles bouncing off right now that are right here? What are they're not bouncing off anything until I put an object in that space, and then they can collide off it, and I can have that change of momentum. And they'll give me, at my altitude, about, 14.7 psi.
Actually, that wasn't quite right, was it? I mean, they do bounce off each other, even if I don't put an object in that space. I was just trying to emphasize the fact that if we're going to measure that pressure, we need to have an object there.
So when you say demonstrate gas pressure without a container, what you're really asking is a question that doesn't really have any legs or understanding to it. You've just admitted that we have a pressure gradient, and the physics perfectly predicts and explains the pressure gradient. As we get higher up into the atmosphere, less particles have been, as predicted by the Boltzmann equation, less particles have been able to get that high in the atmosphere. They've radiated off so much heat into space that they are moving massively slowly. So we have less collisions, we have lower energy collisions, and the pressure drops to eventually zero when we reach space. So my question to you is, why are you, if you're going to ask me, show me gas pressure without a container, why are you acknowledging that we have different pressures without a membrane down here? Like, why can I climb a mountain and suddenly have a lower pressure? You can't ignore that question, especially when you've already shown, let's show everybody what you've already shown. You've already shown that you've got no understanding of entropy. You've already shown you've got no understanding of thermodynamics. You've already shown that you can't explain what causes gas pressure. So you've not started off on a good foot. So why don't you redeem that and tell everybody why we can have these two differences in pressure without a membrane within the atmosphere? Explain, but I want an explanation, because so far I've had nothing from you but comments that lack any kind of scientific reasoning whatsoever. Give me that explanation.
Just question here from Craven Mordic says the Bolton equation. No, I said the Boltzmann equation. That's part of the one of the equations, one of the many equations involved in thermodynamics. But you can use it to predict how high or what percentage of particular gases will reach a certain height in the atmosphere. So, if we're actually going to use the second law of thermodynamics, it predicts perfectly the pressure gradient that we see. But great username, by the way.
I'm holding your toes to the fire. Everybody's waiting. Off we go, buddy.
This is the third time I'm going to ask you to demonstrate gas pressure without a container. Again, you just started talking about the atmosphere and then asked me a question. So can you just concede? Because literally, we can just move on to the next point. Can you demonstrate without talking about the atmosphere for a third time? Okay, without your religious assertion of the sky. Demonstrate gas pressure without a container, Conspiracy Cats. Yes or no. Show me the demonstration if you have it, and then we can evaluate.
All right, I'll tell you what. Nathan, Craig, can you play?
Yep.
We'll get something on, because I think clearly, the people in the chat can see what's going on. Nathan's going to ask the same question, and he's ignoring that we don't need a barrier. And that would be my first answer. There's a pressure difference between here and higher altitude, but it's not a question he's willing to answer. So where's my Mythbusters clip?
I already answered that. I already answered that question in my argument. I already answered that question in my argument, Conspiracy Cats. I said.
Well, the people in the chat can decide whether you did or didn't. And I think I know
what
guys, I'm just going to butt in here. Apparently there's a YouTube problem across the site. People can't log in and things like that, so we may get interrupted. The chat's crashed as well, but there is.
Right, well, while Danny's sorting that out, Rune Thompson says he has a question about nuclear fusion and heat distribution. Fire away, let's see what we can come up with. I'm not saying I can answer it, but let's get the question heard anyway.
4,000 people watching still, so we are still going. If you can wrap this one up within the next couple of minutes, that'd be good. Thank you.
Yeah. Brilliant. I mean, we can wrap it up in 10 seconds. Can you demonstrate gas pressure without a container?
Nathan, how many times do I need to answer that question and tell you, yes, we simply have the differences in pressure at low altitude and a high altitude, and there's no membrane between them? How many times? Tell me why that's not good enough. You explain to me using your scientific understanding, rather than just repeat again, show me gas pressure without a container, which is all you're doing. Explain to me why that's not good enough. Why is that not good enough? I want an explanation.
Catz,
yes, I will. Well, I'll explain it by giving you the definition of gas pressure, and you guys can all look this up yourself. Gas pressure is defined as the body of the molecules in the gas bouncing off the walls of the container. Now, if you don't have a container to gas pressure, entropy will take place, which is the higher pressure system moves towards the low pressure system. I have videos on my channel of MIT professors stating, without a barrier and a vacuum next to her, the gas fills the space rapidly. So that's why the heliocentric model cartoon, there are no real pictures from space of the Earth or South Pole or the solar system or even the sun or satellites. Google this stuff yourself, guys. But they have to fake it, violate the second law of thermodynamics. Conspiracy Catz hasn't demonstrated gas pressure container. We'll wait for the video. But yeah, I'd love to move on because I've asked times and he just keeps asking me questions. And I'm just saying, what's the science? What's the experiment? And I'm waiting for it. If we don't have it, just move on.
We can move on to the next point, but I'm going to summarize very succinctly for everyone watching just what has happened, just so you're not getting away with this. I have asked you to define the most simple, basic terms related to entropy and thermodynamics, and you couldn't do it, and you showed everybody that you have no understanding of entropy and thermodynamics. We've shown that. I asked you to explain to me what causes pressure, and you just used the word press. You couldn't explain to me what causes pressure, and yet you're using the arguments of thermodynamics and entropy to defy the fact that we can have an atmosphere for some reason. But you have literally such a weak understanding of the concepts, you can't even express basic terms. I've asked you to explain microstates and macrostates and Maxwell's demon. You've got no idea, absolutely no idea. I've asked you to explain specifically why having two different gas pressures next to each other, and I'll tell you what, there's a bigger pressure difference down here at 14.7 psi than there is at the top of the atmosphere, than between the top of the atmosphere and the vacuum of space. So if we don't need a membrane between here and the top of the atmosphere, why do we need a membrane between the top of the atmosphere and the vacuum of space? And I've asked you to explain that, but you've got no understanding. All you're doing is you've set your boat to the same troll boat that Nathan Oakley and Quantum Rays do, and you're repeating the same questions over and over. When you've been asked about a definition of something, you've had to Google it and read it without any understanding. So we'll move on from gas pressure, but let all the people in the chat see that you literally had no idea what you were talking about, and you've literally just repeated yourself over and over and read definitions off the screen. So I'm happy to move on because my aim is to show people that you have no understanding, and I've done that. It's not to convince you, it's to convince the people that are listening to you. So next point.
I got loads of emails for that bit, time-stamped. I must have had about 7 emails from people saying they were unsubscribing from me because I was extremely condescending towards Nathan during that bit. Sorry, Nathan. But the point remains the same. You know, you can't bring something as evidence and then when asked to explain the evidence, not be able to understand it. That's just ridiculous. Crafty Kilo, I just want to say big thank you. And she makes a good point. She says over 150 people could help by clicking like, and I'll not argue with that if anyone wants to whack that like button. Anyway, just before you thought it couldn't get any worse for Nathan Thompson, it's about to. But have we got any questions in the chat? Let's just have a look. Any sort of questions? I have had some good ones about why do flat earthers believe certain things, like how do flat earthers explain the magnetic field? How do they explain solar flares, etc.? I don't know the answer. I don't know the answer to those. So if anyone can help us out, let's do that. Right. Tommy Gonvold, you should have a medal for that part. Oh, thank you very much. Right, I'm going to press play, and then when I get another question, I'll pause it.
We'll move on from gas pressure.
Thank you very much, Catz. So that was a good first exchange. We'll move on to Catz, your first point, please.
Okie dokie. Right. Craig, can you bring up slide 30? Oh, not 35. Let's have a look at.
By the way, my favourite internet moment of all time is coming soon.
I've got it here somewhere. I'm just trying to remember which one it is. We'll have slide 10, please, pal.
Slide 10. The latitude lines one, yeah.
Yeah, it's got 9 on the picture, but it's slide 10.
This one.
Yeah. Right, Nathan. Do you know what you're looking at here?
What's your argument? I mean, it's your argument. Go ahead, explain it.
Okay. So my argument is something that we can all do. The people who are considering listening to you in the chat can do this for themselves. They can measure the angle of Polaris in the sky. And they can then, when they go on holiday or move, go to a different latitude, or just for the day, go and drive 111.3 kilometers north, they can see that the angle of Polaris in the sky will drop by 1 degree. Now, on a spherical Earth, that is absolutely predicted because the horizon, essentially, or the floor we're stood on, is our tangent line to the globe, if you like. And only on a sphere will we see that 1 degree shift for every 111.3 kilometers that we drive. Only on a sphere. But if we have a look at how it should appear on a flat Earth, and that is, Craig, I'm going to need another picture. If I can get the right one. Right. So if we look at slide, it'd be 35, please. Right, now here, and I've modeled what happens. So I'm not suggesting that Polaris is 64 kilometers away for anyone who's in the chat or anything like that. But what I've done is I've taken 2 pictures that are 111.3 kilometers apart and 1 degree apart. And what we can see here is that what we call the opposite. Do you know what I mean when I say the opposite, Nathan?
Yeah, I've heard the word opposite once or twice.
Because we're going to look at something, trigonometry here. Can you just explain to me, just so I know that I don't need to explain to you, how you would calculate the opposite in those triangles, please?
The opposite
how
angle?
Would you No, the opposite. It's what I've circled in red. How would you calculate that distance? Using trigonometry, how would you do it, Nathan?
Are you assuming we can triangulate distances to the sun?
I'm going to play that again in a second, but this is genuinely where I think a lot of flat earthers have the problem, is that because they can't do basic trigonometry or geometry, they don't even try, they don't understand the significance of the points. When you talk about things like Polaris, they don't understand it's significant because the people on YouTube hand wave it away and say, oh, it's just looking at stuff in the sky, you can't tell anything about what you stood on by looking at the sky. And that's because you just don't understand the significant, they don't understand trigonometry, so they don't understand how significant this observation is, and clearly he's not done trigonometry for a very, very, very long time, and he's not even tried in all his flat earth research, he's not even tried to do to look into one of the best proofs of the globe, Shame, really.
No, I'm saying pretend it's a maths test. Let's pretend that you've got the angle that I've given you and that you've got that distance on the blue line that I've given you. And all I'm asking is, forget the Earth, forget Polaris, forget anything like that. Treat it as a maths question because I want you to know the significance of what's about to happen. How would you calculate the distance to Polaris there? How is your trigonometry? Can you do it? And by the way, trigonometry is something we teach to 12-year-old children in England. I'm just pointing that out. Can you calculate that distance? That was a low blow. I apologise for saying that to him. How would you calculate it, Nathan?
I mean, so your argument is that the north. I personally can't calculate that. I don't work in kilometers. I normally work in miles.
I'm sorry. I just have to stop that just to That's my favourite moment ever. He can't do a trigonometry problem because apparently the laws of geometry are different if you work in kilometres than miles. So my favourite internet moment of all time. Anyway, I'll let it play for a few minutes until I see a question now. Here we go.
And the distance to Polaris, I have to see your measurement. I'd have to see your measurements for the distance to Polaris. Is that what you're trying to show right now? Is triangulating the distance?
No, it wasn't. I'll carry on with my explanation. I think everyone who's watching understands the point I've just made. What I'm saying here, if we use basic trigonometry, which is the kind of stuff that 11 and 12-year-old children learn, we would know that we can calculate what I've represented in that vertical blue line there as a distance to Polaris. And on a flat Earth, if we move 111.3 kilometers and we have a 1 degree difference, you can see from just both those diagrams that the distance to Polaris has to change. Now, the significance to this, Nathan, and this is why I was asking, you know, I really want you to understand what's going on. The significance is it is physically impossible for somebody on a flat Earth to move 111.3 kilometers and see Polaris shift in the sky by 1 degree. It would have to shift by a much, much bigger amount or smaller amount. It will not shift by 1 degree. The trigonometry is basic. An 11-year-old child would know that moving that line by 111.3 degrees would not change the viewing angle by 1 degree. This completely blows flat Earth out the water. End of. No more discussion. There is no discussion. This shows that the observations of Polaris completely disprove a flat Earth. Now, I put a video out not so long ago, and I challenged people. I said I will delete my channel if people can come up with an Earth shape that is not a sphere, that explains this perfectly in the northern hemisphere and the equal perfectly in the southern hemisphere. And you know what? My channel is still there because nobody could mention it. So my question to you, Nathan, is given the fact that this basic trigonometry, this 11-year-old mathematics completely smashes flat Earth out the window, how do you explain the observations of Polaris? Or do you need a little bit of time just to Google a bit of trigonometry?
No, I don't need any time. I really just need 30 seconds on this. I'm actually surprised you're even using it as an argument.
While he gives us the answer, Runethorn, so I've read your questions. Can I just, I'm not being, can you just type them again? I'm a little bit confused about what it is you're asking when you say the core is constantly growing as the available hydrogen is in a sphere band around the core. Just explain that bit for me, and then link that to what you mean about the heat escaping, and I will get back to you on that as soon as you've rewritten it. Thanks.
The stars have been observed for thousands of years, guys. It's actually one of the reasons I know that the Earth is stationary is because we have a perfect clock and a perfect map above our heads. Now, when they say Polaris, they mean pole star. That's what Polaris means. Now, notice Catz did say Sigma Octantis once, because Sigma Octantis is not analogous to our northern pole star. Sigma Octantis, if you watch time lapses, moves, and also it's not visible from every area south of the equator. That our northern pole star is analogous or can be seen anywhere north of the equator. So they use it to navigate because it is stationary. That's why he keeps bringing it up, is how fixed it is and how you can determine your man-made latitudinal lines off our fixed Polaris. But like I said earlier, the Earth is allegedly moving at supersonic speeds, 66,000 miles an hour, tilted around the sun, while the sun goes 20,000 million miles a day through space. So if you think that a stationary northern pole star is a good argument for being on a spinning, tilted lava ball blasting through the infinite vacuum of space, and you're going to talk about how it declines towards the horizon, well, I'll just point out sunsets and airplanes. Same thing happens. Anything that's above your head that moves from you goes down towards the horizon. It is very simple. It is perspective. We can pretty much move on from there. I'd like to hear your next argument.
Bollocks. Bollocks. I was muted all that time, wasn't I? I'm going to have to go through that again, and that was so good. I bet Creaky's wetting himself laughing. Someone made a post before and said now everyone knows what Creaky does on the show. Yeah, he's like a genius when it comes to this. So, right, I'm going to answer Rune Thornson's question again for the second time. Right, Rune Thornson said, he's talking about nuclear fusion in a star, and he says he thinks there's a problem. He says, so the helium product from hydrogen reactions ends up in the core, which is constantly growing as the fusion happens, and the hydrogen is in a sphere band around it. This process should run out of control. I'm not sure why he said that, unless the heat from the reaction can somehow diminish the amount of hydrogen given off. How does this heat escape? Right, I'm going to tell you what I understand about nuclear fusion, because your questions confuse me a little bit, and then can you tell me, just elaborate on anything that I've said, and I'll come back to you later on. And obviously there'll be more people in the chat that understand this a lot better than I do. But essentially in a main sequence star like our sun, you've got protons, and those protons collide together because of fusion, and those protons are essentially the hydrogen atoms, hydrogen nuclei, sorry, and when they slam together to form helium nuclei, they lose a little bit of mass. The protons inside the helium don't weigh as much as the proton when it's separate and it's part of the what we call like the hydrogen nucleus, if you like. That mass that's lost, E equals mc squared, is converted into energy. At A level we talk about binding energy and mass defect, etc. But basically when that fusion happens, mass is lost and energy is given out, and that energy is what we see as the light and the heat and the electromagnetic waves we get from the star. So you said, how can that heat escape? Well, ultimately there's two forces in a star that balance it. We've got the gravitational force pulling it in, and the heat that's generated by that fusion is causing an expansive force that's pushing the star outwards. And in a main sequence star like our sun, those forces are balanced. But as time goes on, right, and I'm sure people can give a far better, more detailed explanation than this. I'm just giving the one we use at school. As time goes on, mass is more and more mass is lost. So that gravitational pull pulling the star in gets weaker, and that triggers a series of events which causes the expansion of the star into a red giant. So you talked about how does the heat escape. It does take a long time for photons to go from the middle of the, I think is it thousands of years even, photons to go from the center of a star to the surface of the star, and then 8 minutes to the Earth. But that's kind of like how I understand what goes on in a star. So if you want to just pose your question of, you just said again there should be a nuclear meltdown, and I'm not sure why you're saying that. I'm not sure why you're saying there should be some sort of meltdown or whatever. I don't know. If you can give a reason for that, and then I'll have a think. But let's get back to Nathan.
Well, I'm sure you would, because this argument is killing you, right? And I want to stay on this a little bit, because Nathan, what I'm saying is essentially this: if I'm at, let's say, 53 degrees latitude, right? Whether you want to use the term latitude or not, if I drive 111.3 kilometers south, right, Polaris will drop 1 degree in the sky. And if I carry on driving that distance south, Polaris will continue to drop 1 degree in the sky. Now, if we can get that picture back up, because what I'm going to show Nathan here, right, is that literally
exactly what it does.
Yeah, it's exactly what it is. And the only
when the sun moves
away, Nathan, this is my point now. The only reason this can do this is because of the geometry of the land we are moving across. If we were moving across a flat plane, it would not drop by 1 degree in the sky for every 111.3 kilometers. A flat plane does not cause that to happen. What I'm saying, and if you, and essentially I'm doing this for the people in the chat and the people who follow you, because the people who follow you understand basic trigonometry. This isn't about convincing you, it's about showing everybody in the chat. Not only do you not understand entropy, not only do you not understand thermodynamics, not only do you not understand pressure, but now you are showing 4,000 people that you don't understand basic trigonometry that 11-year-old kids do in school. And yet you are still running an internet group telling people that the Earth is flat when your ignorance is on display. And I don't want you to say that personally, because I'm saying this with people who are considering listening to you. I've got to make it clear to them, so they can, because they'll understand trigonometry. They'll have done it when they were 11-year-olds, Nathan, right? They would have done trigonometry when they were 11-year-old. If you can't understand the significance of that, you couldn't even tell me how you calculate the opposite on that triangle. You didn't even know what the opposite meant. But yet you're going to stand there and just dismiss it and go, oh, things just move You know, if that's your answer, Nathan, then we can move on. But I think I've made my point to the chat. So that was my point. It's your go. Off you go.
Yeah, well, like I said, it's stationary. Wouldn't work if we're blasting through space. That's why sailors use it to celestial navigate. I'm honestly surprised you're even using this as an argument. So, cool, good stuff. Next argument is my turn to sign man down.
Thank you. Yep, it's your second point now, Nathan. Thank you.
Excellent. Well, I'll start with, according to the scientific method, do we have to manipulate the cause of the effect to prove scientifically the cause of the effect, or can we just observe and declare what the cause is? Conspiracy Catz.
Well, you know, it's a good question for me because I'm a science teacher, and we teach the scientific method all the time. And unlike what people like Quantum Eraser and Nathan Oakley would have you believe, which is what you are parroting now, or I assume you're going to parrot, you know, science isn't exactly what you think. When we look at an independent and dependent variable, we're looking for a link. We're not looking for a cause. Let me give you an example. If I'm driving a car, Nathan, and I put my foot down on the gas pedal, the car speeds up. Now, what is the cause? Is the cause me putting my foot down on the gas pedal, or is the cause a complex mechanism in the engine which is causing the car to accelerate? Now, if you're going to take your model and this stupid egg and saltwater model that Anthony Riley, you know, likes to throw around, then you are ignoring the complex mechanism. So I'm just going to ask you this one simple question, and then you can go on. When I put my foot down on the gas pedal, what is the cause? Is it my foot, or is it the complex mechanism in the engine? Go.
Before we do that, I just want to say a big thank you to Gently's channel saying read the chat. I am trying to keep up with the chat, and thank you very, very much for that. Rune Thompson, just again, or at least I'm not muted this time. You seem to be saying that the for some reason the temperature in the core of the sun just should be getting hotter and hotter and hotter and hotter and hotter and hotter, and I don't know why you're claiming that. Maybe go and have a look at the amount of energy, the binding energy involved in the fusion of hydrogen to lithium, hydrogen to helium, helium to lithium, etc. You know, I think there's a whole body of stuff there that you're sort of ignoring. Have a look at how the forces that the gravitational force and the expansive forces change as the mass of the sun changes. You just seem to think fusion is going to make the sun get hotter and hotter and hotter, and you're not really giving a reason why. You know, of course, it's extremely complicated. You know, go and look into it.
Well, science deals with the observation of natural phenomena. So we really don't have to red herring anybody talking about ours or anything. We could just talk about the natural world and what is happening in the natural world. So, Conspiracy Catz, help me understand your argument, not using a complex man-made engine, like scientifically using nature. What could you explain to me? What would be your best argument that you're trying to give here?
Okay, so my best argument using nature, let's just go back to one that we've done recently. How about if I make my independent variable the geographic location I am on the planet? Because I can manipulate that. I can stand where I am now, and I can go 111.3 kilometers south. I can manipulate that. That is my independent variable. My dependent variable, Nathan, can be the angle of Polaris in the sky. How about that? And then when I make that 111.3 kilometers, Polaris will move. Now, does that mean that I am causing Polaris to physically move? Yes or no?
No.
Am I causing Polaris to physically move? Well, exactly. Case closed.
Well, you're causing
the independent variable is not the cause. The
independent variable is not the cause. Well, the cause of the angle of Polaris changing was you changing your location. So it did show a cause and effect relationship. But the thing is you know, we don't have a way to like wiggle or test the stars. We can make observations and we can make predictions. You don't really follow the scientific method by observing stars and then making observations. You have to have a way to relate the cause of the effect. And so I guess I'll just move on to my next question. Could you define Coriolis, please, just to make sure that we're on the same page? Because I don't want, you know, us to not be on the same scientific terms. So what would be your definition of the Coriolis effect manifested because of Earth's rotation, please?
Well, I'll do that, Nathan, but what I'll point out is when I'm defining my understanding of Coriolis, I'm not Googling it and just reading a Google definition. I understand it, okay? So the idea, the Coriolis effect, I said I understand it, and I couldn't pronounce it. The Coriolis effect essentially is due to the conservation of momentum. When the Earth is moving around and anything's placed on the Earth, it is moving with momentum in the reference frame of the Earth, right? So it might be stationary, but it's got its momentum and it's moving along with the Earth. If I then suddenly start to move northwards or southwards, then because the Earth is a sphere and the radius of, or the circumference of that sphere shrinks as I go to the north or to the south, then there's a change in the relative velocity of me and the ground beneath me. And that appears, it manifests itself as something curving. So if I'm at the equator, I have a greater velocity, a greater linear velocity than something that's maybe at the 45th parallel. But if I then suddenly levitate and start flying towards the 45th parallel, I'm going to appear to be moving faster than that part of the ground. Now, you notice I didn't have to Google a definition of that.
Excellent. So just for a little clarification, is the atmosphere a secondary reference frame from the Earth?
Muted again, and this is something that really annoys me. You know, it's like a tactic from Nathan Oakley or Quantum Eraser, isn't it, where you try and discuss a subject like Coriolis effect and then they want to hook onto these little questions that are really, you know, have been answered or are irrelevant. You know, it's the whole, is the horizon geometric or apparent at the minute? You can talk about refraction, you can talk about the horizon, and it's almost like they just don't listen to you at all. They'll just fire that question at you because it stops them having to engage in anything that requires them understanding, for example, the Coriolis effect. Yeah. And
so you going with the idea that the atmosphere moves with the Earth? Is that what is this where you're going?
I'm asking you to define Coriolis. Now, do you think the atmosphere? I know when you go north and south, what about east and west? If you're traveling east, does the Earth rotate underneath you?
Yeah, well, you've got to, and you've got to realize the importance of conservation of momentum. If I'm on a train, for example, right, and I throw a ball up and then I catch it, when I've thrown the ball up, the train has carried on moving, the ball is carried on moving, but it's appeared as though that object is stationary. Is that true or false? Can you tell me, is that true or false, Nathan? Can you be honest?
Yeah,
and just answer true or false?
The issue with the train is you're in a closed system moving in a linear direction. There is no, it's relative. So if you're moving in a linear direction with not accelerating or decelerating, yeah, when you're in a system, you throw the ball in the air and it comes right back down to your hand. But being on a spinning ball and being inside of a train going straight is not the same thing, Conspiracy Cat. So I would submit that would be what's called a false equivalence fallacy, where you try to compare two things that don't even relate at all whatsoever. So I'll ask you again, because science is the observation of the natural world. Does the atmosphere move separately from the Earth? Yes or no?
The movement of the atmosphere is influenced by the movement of the Earth, but obviously they're not joined like a solid. That's why, and to answer your question in full, that is why storms in the northern hemisphere rotate in the opposite direction to the southern hemisphere. So the movement of the atmosphere that you're trying to use as somehow proof of flat Earth is actually proof of the globe Earth. If you want to talk about Coriolis effect, then how can you explain the opposite movement of storms in the northern hemisphere and the southern hemisphere? How can you explain that? Because that's Coriolis in action. That is explicitly addressing your point of the atmosphere moving. How can you explain that opposite rotation? Off you go.
Of course. So are you saying that the clouds, which are in Earth's atmosphere, are rotating separate directions because the Earth is moving underneath? Is that what you're saying, Conspiracy Cats? Just so we're clear.
No, what I'm doing is I'm applying my understanding of the Coriolis effect. So, and I think what's happening is you are, just like you did with thermodynamics and you couldn't demonstrate an understanding of that, just like you did with pressure and you couldn't demonstrate an understanding of that, just like with trigonometry and you couldn't demonstrate an understanding of that, just like independent variables where you couldn't demonstrate an understanding of that, you are not demonstrating an understanding of the Coriolis effect. Yet again, you are misrepresenting and misunderstanding science. So let me explain it one more time to you. When the Earth moves northwards or southwards from the equator, it is traveling at a faster speed than the land below it. And I've got a video on this on the Baldy Catz channel. If anyone wants to know, look at the Coriolis effect on that. And that creates this opposite movement as the Earth is moving north or south. Right? Now that's important. As the Earth is moving with any kind of vector northwards or southwards from the equator, we are going to experience that kind of effect. For you just to say, does it affect the clouds as the Earth spins, shows that you don't even have enough of an understanding of the Coriolis effect to formulate a proper question about it. You need to clarify your question because it literally makes no sense.
What's the betting that he asked me, does the atmosphere move with the Earth? But again, you know, I think like the debate I'm going to have on Wednesday will be a completely different tone. You know, I came into this debate just with the idea of showing everybody that Nathan Thompson didn't have a clue what he was talking about, and I think successfully we've shown that. But I'm debating the mind of God, just putting that out there, on Wednesday on this channel. And that I'm looking to make much more of like an educational affair. Hopefully the mind of God will react to it a little bit better than this. Anyway, I forgot what I was going to say there. Let's see what he says.
Can you clarify your question, please?
I'll try and make it clear, really concise for you. When an object enters into Earth's atmosphere, going north or south or east or west, or even just hovering above the Earth, does the Earth rotate underneath the atmosphere, or does the Earth drag the atmosphere with it? What do you think? Conspiracy. What does the science tell us?
That's a better question. There is a certain viscosity to the atmosphere, so there is a certain amount of drag. Now, that has taken millions of years to get the atmosphere to be moving as relative to the Earth as it is at the minute. But they're not, like I said, they're not fixed and bolted, so when the Earth moves, you know, it's dragging in real, you know, it's physically dragging like you would a solid object. But that viscosity over millions and millions of years has accelerated the relative movement of the atmosphere with us. But that's not like that's not to do with what you were talking about before. I don't understand how that's got to do with static clouds, or I still don't understand your question.
And before he explains it, Wolverine 6668 has said, does the water in the southern hemisphere go the opposite way to the north due to the Coriolis effect? Well, I think the most important, from what I've looked at, the most important thing about water, I assume you're talking about draining down a hole or something like that, are the forces applied to the water as it's because of the shape of the sink. So as it sinks, if the sink has imperfections in it, that's going to have more of an effect on which way the water spins. Also, which side of the tap you've had on to start with, that's going to create some sort of momentum, because the Coriolis force, it's not strong enough to overcome those. So there we go. Let's have another look. Yeah. So in theory, yeah, but to actually demonstrate it, it'd be very difficult.
Yeah, of course. Yeah. So, real quick, the movement of the storm systems has nothing to do with the rotation of the Earth. A very popular channel called Physics Girl, she ran through water, which air fluid, it behaves very similar to the properties of water. So, fluid statics is the study of fluids at rest. Fluid dynamics is the study of fluid. So, as the sun and moon rotate around the polar center of the flat Earth, they're creating vortexes in the sky. Now, you can observe these vortexes swirling in opposite directions when you move a plate through a pool. Now, she has a video with 7 million views where she simply runs a plate through the water, and you'll see that the wake from behind the plate creates vortexes that rotate in opposite directions. Now, Same thing's happening when the sun and moon move through the air. They drag the atmosphere with it and create what's called an electromagnetic wave.
You know what? This is typical of, like, I think, to me, flat Earth is like a broken spreadsheet. You can fix, if you've got a spreadsheet and you've got all these little interlinking formulas. I mean, I know Rune is in the chat. He says he likes that argument. Well, this is my response to it. If you've got a spreadsheet that's got loads of like interlinking equations and formulas linking cells together, and then one of them breaks, it has a knock-on effect with something else. And flat Earth is like that. You know, Nathan Thompson here, to try and somehow explain the Coriolis effect, has had to put the moon and sun right in the Earth's atmosphere. But then you get all the problems about having the moon and sun in the Earth's atmosphere. That doesn't explain why there's no change. They'd have to be very, very small, wouldn't they? There's no change in angular size. Why do we only see one side of the moon? How does that explain eclipses? How does that explain seasons? What's keeping them up in the atmosphere if they're more dense in the atmosphere? And the whole thing falls apart. And this is, you know, what I'm going to be talking about with Mind of God. The title of the debate on Wednesday is, why isn't there a model for flat Earth? And the reason there's not a model is because when you try and come up with ad hoc explanations like that for something, immediately everything else around it just crumbles like a sugar pedestal in the rain, doesn't it? You know, there's absolutely... there's no way you can fit in anything like eclipses or seasons or anything if you're going to drop the moon and sun into the atmosphere like that. So there you go.
So this is easily explained in a flat contained Earth. What my argument is that they claim Coriolis affects sniper bullets, and the Earth rotates underneath objects that go into the air, and this can be seen by Neil deGrasse Tyson. He made a tweet that said a field goal was made or missed based on the Coriolis effect. Once the ball entered the atmosphere, the allegedly rotating Earth rotated underneath the football and caused the kicker to miss the field goal. Now, if this were the case, if so, that would rotate under helicopters, hot air balloons, airplanes, and the Felix Baumgartner jump, which lasted 3 hours. He is for 3 hours and landed back in New Mexico, 50 miles from his destination. Now, according to the Globe math, at Santa Fe, New Mexico, Earth does not rotate 15 miles an hour. That would be somewhere near the North or allegedly South Pole on their equator. But at Santa Fe, New Mexico, it's rotating well over 500 miles an hour. And Felix Baumgartner, if Earth was rotating under him, should have been somewhere in the Pacific Ocean. Because, as claimed by the Coriolis effect, Earth is rotating under objects that enter into the Earth's atmosphere. The problem with this, the reason I bring up this argument, is that we do not observe this. Earth does not rotate under sniper bullets or hot air balloons or airplanes or smoke or insects or balls you throw in the air.
And meanwhile, back in the real world, any World War II historian will tell you how the Germans got very, very good with the long-range projectile weapons and how they calculated and had to calculate for the Coriolis effect to hit the target.
And it's very obvious. So, I mean,
okay,
that's pretty much it, unless you can demonstrate a Coriolis effect without pointing towards vortexes in the sky, which are easily explained on the flat Earth model. I mean, I'm surprised you have you heard of electromagnetic wakes, Conspiracy Cats, or is this all new information to you?
Have I heard of electromagnetic waves? Well, I've written that down. Nathan, I've got a few things I want to respond to that. First of all, if you're suggesting that something moving through the air is the cause of electromagnetic waves, electromagnetic radiation, then I don't even need to address you on that point.
I think he said electromagnetic wakes. Wakes.
Wake.
Yeah.
Yeah, like a wake from a boat. Like a wake from a boat, or the wake from the plate being skimmed across the surface of the pool creates vortexes going in opposite directions. Yeah. Works perfectly fine with flat fluids. So I think your argument for a spinning ball Earth, really.
So let's look at that. The fact that we can predict, right? We have these weather, meteorology and weather system prediction is fantastic. The fact that we can predict when and where we're going to have hurricanes, tornadoes, the size of these tornadoes, etc., all based on our understanding of the science of how the atmosphere works and the Coriolis effect. The fact that we can predict that with a T, through it is amazing. And the fact that you are willing to essentially say what I saw the Morgal say in a video, he used an analogy where somebody just waved their hand through a bathtub and that created a bit of a, you know, a vortex on either side. The fact that you're willing to again show that you've got literally no understanding of the science behind it whatsoever, but you're willing just to say, you know what, if I wave my hand through some water, I get these swirls on either side. That could probably do it. Now, my purpose for this debate, Nathan, isn't really to upset you, and I don't want to upset you, and I think you're a good guy, and I'm not here to fall out with you. But the purpose for my debate here is to show the people that are on the edge of flat Earth, listening to what you've got to say, that you have no understanding whatsoever. And you've just yet again tried to take something as complex as meteorology and say, yeah, it's just like somebody waving the hand through a bathtub, making the water spin on either side. I mean, seriously, can you not explain it in any more depth than that? Then you say, yeah, it perfectly works on a flat Earth. Well, Nathan, I don't even know where to go, and I don't even think I need to address that. I think the people in the chat can see, and I'll go over this again because it's for them, that you had no understanding of thermodynamics. You couldn't explain what pressure was. You couldn't explain what an independent variable was. You couldn't explain how to do simple trigonometry. You didn't understand the significance of the observations of Polaris because you don't understand simple trigonometry. And now you're trying to equate complex meteorological science with running your hand through a bathtub. You know, you're not going to agree with me because you don't have the understanding to see how wrong you are. And there is a term for that, and that term is Dunning-Kruger. You don't understand how much more there is to learn than you already know. You just don't get it.
And I think that is just Rune Thompson has just said, it's just an idea on how it could work. And I think that's a problem, Rune. And I'm not having a go with you here. I know you're always respectful. Oh, thank you very much, Brain of Steel. Not at 200 likes yet. Yeah, I'd love it if you could get to 200 likes. But thank you, Brain of Steel, for that. That's the point, Rune. You can have these ideas about how things work, but when they're presented by people like Nathan Thompson, that has a Facebook group with over 100,000 members, he's not presenting ideas. He's saying the Earth is definitely not a globe, the Earth is definitely flat, and this is how the Coriolis effect works. All right, and then people that don't know any better, that just like him don't do any research on even the most basic fundamental skills like trigonometry, they just look to him as somebody to believe, and then they'll fall for it. So, you've got to have some sort of explanation. And I think in that debate there, that's what I tried to do, just show that he had no explanation, no substance, nothing at all to back any of his claims up. And I think that's what Flat Earth is start to finish, which will be, again, I don't know, I'm advertising it, it will be the debate that we'll be having on Wednesday. Why is there no Flat Earth model? And the answer to that is because every single model or explanation that comes up for Flat Earth either contradicts something else in the real world, so it can't work, or it just doesn't work itself, And if I was a Flat Earther, and this is my monologue before I sign off, if I was a Flat Earther, I would be asking myself, it's not about having a model that works. It's about having a choice of things. So you could look at the Earth and say, right, what shapes could the Earth be? Right? Could it be a globe? Do the things work on a globe? Could it be a pizza dish? Could it be this shape? Could it be that shape? Could it be this shape? And then you start to rule things off, Rune, and say, well, you know what? Daytime and nighttime wouldn't work on that shape. Seasons wouldn't work on this shape. And you narrow things down, so you get what you're left with. All right? Now, the problem is that for Flat Earthers, they can't choose. They haven't got a range of models left. All right? I'm not saying you've got to believe in one, but surely you should have a range of models that work for different things, and then you can say, right, well, we'll investigate which one's right. But you haven't even got a selection to start with, because none of them work at all. And that's what I'll be putting to the mind of God. And it'll be I'll be certainly more respectful and toned down against the mind of God. I'm a changed man. And I'm in my 40s now, I'm getting a bit older. But we do finish at 9 o'clock. This show always finishes at 9 o'clock, and I did want to get through the debate, but it is on Simon Dan's channel if you want to see the rest of it. We're up to the 1 hour, 9 minute mark, and I think it just goes into a bit of questions and answers after that anyway. If you don't know who Simon Dan is, I'll make sure he's linked in the description, but I'm pretty sure you all do. Before I sign off, I will just have a look, see if there's any more questions in the chat. B-Wolf Live, yeah, I am debating Mind of God this week, and it is on this channel Wednesday night, 7:15 till 9 o'clock. I did say at the beginning, this isn't really going to be a flat earth channel but because we happen to be having one flat Earth debate this week, that's why I brought tonight's little review, make it a bit of a flat Earth week. And then next week we're going to be looking at something I'm really interested in. We have the issue of, should psychics, mediums, clairvoyants, fortune tellers, should they be legally allowed to charge for their services? And we have two people, very articulate people, very experienced people in their fields. I'll not spoil it, but I'm really looking forward to that debate. So I'm just going to say goodbye to everybody. Although there's 248 of you, so I can't call you out by name. I will just hang on for 10 seconds, see if there's any more questions, and if not, I will wrap things up. Let's have a look. Question for Catz. Could you tell us your hair care routine? Yes. It doesn't take long. I get my beard trimmer, and I just shave my head with it once every couple of days. Let's have a look. Yeah, people saying bye now. Mr. Andret says he doesn't know Simon Dan. I'm pretty sure you know Simon Dan. Just I'll tag him in the chat for you. There you go. So you can click on him and go to his channel, I think, if you're still allowed to do that. FA peer review. Yep, psychic should be very interested. I'm really looking forward to that. Really looking forward to that. Anyway, that's it. So thanks for joining us. That was a bit of preparation for me. I've not watched that back really since we did it first time live. So yeah, it's been a bit of fun. Thanks for the questions. Thanks for engaging. Thank you, Creaky, for being in the chat and letting me do this one. And I think everyone can see why Creaky is so important after all my mess ups.